So raise your hand if you ever tested directly on production data. Okay, that's good. That's good. So, hello everyone. My name is Guy, and I'm proud to be a founding developer and part of the core team developing lakeFS over the past few years. Being deeply ingrained in the open source community has been an incredible journey. What I value the most about this space is the collaborative atmosphere, passionate developers working together, addressing challenges. You can't hear me? Providing solutions that benefit not just them, but the broad community. With that backdrop, I'm here to talk about the synergies between lakeFS, data versioning, and the development of Airflow DAGs. Oh, sorry. So, today I'll be talking about a challenge that confronts many data engineers, and that is maintaining the integrity and reliability of the data managed by Airflow DAGs, especially during the development phase. Now, while Apache Airflow has revolutionized the way we manage workflows, it also brings a set of complexities regarding data dependencies and the potential risk when testing on live datasets. I will demonstrate how lakeFS can help overcome these complexities and boost your confidence in production data. So, first of all, what is lakeFS? So, raise your hand if you know what Git is. Okay, so that makes it easier. So, lakeFS is an open source project that is basically Git for data at scale. We have many companies working with lakeFS in production for various use cases, both for data engineers and data scientists, such as isolated dev test environments and reproducibility for model training and recovery for production issues, and many more. Now, the talk today is around Airflow, but the concepts and the solutions that will be discussed can be applied to a various set of data tools. So, if you're familiar with Kubeflow, for example, you'll see the similarity when developing complex workflows in Kubeflow. So, regardless the tools you're using, the challenges remain the same, and so do the principles of working with them. So, one last thing before we start talking about how we test our workflows, let's talk about what is Airflow, and more specifically, what are DAGs. So there's typically a few steps one would go through in order to gather data from different sources and shift them to be valuable data to the data customer. That could be extracting the data, cleaning the data, filtering the data, and loading it back to the data lake. Now, in the past, we would manage these tasks with cron jobs, which was very difficult to maintain and manage. Apache Airflow is an open source project that manages this orchestration for you. One of the core concepts in Apache Airflow is workflows, or DAGs, directed acyclic graphs. These graphs describe the steps we just mentioned. So in this example, we'd have a few steps for extracting the data, another few steps for transforming the data, and another step for loading the data. In real life, a workflow would look more like this. And managing these workflows is complex, and a minor mistake may harm the quality of the data and require a significant amount of time and effort to recover from. Not to mention the risk of providing incorrect data to the customer. So now that we covered all that, let's talk about how we test and how we develop our workflows. So the first thing we do in testing would probably be integrity tests. That is to test the configurations and the structure of the DAG. So we would check that the DAG is free of cycles, that it loads without errors, and that it adheres the guidelines set to us by the project or the organization. The second would be unit testing. We will test each part of our DAG independently, such as tasks or operators. We may even choose to use tools like Docker to make our tests even more comprehensive. Now, unit test is only testing part of the whole, and if we want to test that our DAG runs smoothly, we engage with integration tests. That is, testing how different parts of the DAG interact with each other. We may even choose to run the complete DAG to ensure overall compatibility. Now, in addition to all these tests, we also have Airflow environments for each step in our development lifecycle. So, how would this look like when developing in our development lifecycle? So, we would probably start out with developing locally with some local tool. We may choose Airflow Breeze. Once we tested locally and finished developing, we can move on to our staging environment that is a shared environment. And it's identical, well, almost identical to production. And only then, after we tested everything, we feel comfortable enough to move on to production. So why do we still here? After all that effort, just please promote your changes to production on Monday during the deployment window, just in case something goes wrong. We'll have enough time to fix it. So the answer to that is working with data is hard. When it comes to data, things are constantly changing. Our business logic may change. The tools in our ecosystem may be upgraded, and the schema of our upstream data may evolve. Now, the effect of these events is very hard to predict or test. And probably the biggest challenge here is, what data do we test on? So we may choose to test on our production data. Take a leap of faith and just run everything on production. That would be the best test ever. So good, we often find ourselves doing it, even though the damage might be disastrous. Another option would be to copy a small sample of the data and test on that. But that wouldn't reflect the real case. Another option would be to copy all of the data and test on that, but that's a huge amount of data. And there's another strategy, having a specific tailored data sample for each environment. Now, although that sounds promising, that is still very hard to maintain and still doesn't reflect reality. So what we basically want is data significant enough to test on, but easy enough to maintain. Now, what if we could manage our data the same way we manage code? Every time we're creating a new feature, we just branch out of our production data and run our tests over there. So now we're basically testing on up-to-date production scale data without tedious copying and without the risk of affecting our production data sets. So lakeFS makes this possible by providing Git-like capabilities to your data lake, such as commits, branch, and tags. So let's consider your current data ecosystem. Accessing lakeFS would be identical to accessing your object storage. The minor twist is you now need to reference the branch you're working on, such as production, dev, staging. You may even reference a specific commit, just like in Git. Now lakeFS also comes with a CLI and a handful of SDKs, so you could run these operations in your favorite way. So let's circle back to our environments and see how this would look like with lakeFS. So all three environments will be directed to the same lakeFS repository. And each environment will have its own branch. So kickstarting a new feature, no problem. Just create your dev branch and run your local environment on top of that dev branch. Once everything is tested and your code is ready, you could just move on to the staging environment and run your tests against the staging branch. And now, after you tested on an environment identical to production and also on data identical to production, you could feel free and safe to move on to production. So let's see a small demo. So for the demo, I chose the New York City public taxi dataset, which is published every month with data relative to 2 months ago. And my DAG runs once a month and has these 2 steps. Extracts the data and transforms and loads the data by cleaning up unknown locations from pickup and drop-off. My environment currently has only Airflow and S3 without lakeFS at all. And in the demo, I will create a lakeFS repository, import the changes, import the production data from S3, create a dev branch, and run my local environment on top of that dev branch. So let's see a recording of that. Let's see how it works. So the first thing we'll do is create a new repository and choose a location where it will exist in S3. Once we have a repository, we could import our production data. And now we could just look at the data and even look at a small sample of a specific file. And now it's time to create a branch. So we create our dev branch out of main. And currently both branches have the exact same data because dev just got out of main. And now we can spin up Airflow Breeze. I'm sorry about that. And once Airflow is running locally, we could go to the UI. Let's take a look at our DAG. And now we can trigger it on our dev branch. Now, production data wasn't harmed, didn't change. And if we look at our dev branch, we could see the new data we just created. We could take a look at a sample of it, look at the pickup and drop-off locations, and we could look at our uncommitted changes. At this point, we could choose whether we want to commit our changes or revert our changes and go back to developing and fix our code. So one second. Okay, so let's recap what we saw. So why does it look like this? I'm sorry. Let's recap what we saw. So we saw that with the power of branching in lakeFS, it's easy to get an isolated environment and test on up-to-date production scale data. We also saw that it's easy to recover when we're using Git-like data. So even if you make a mistake, you just roll back to a known good state. And using lakeFS is identical to using your object storage. You just now have the Git-like capabilities. So this was just the tip of the iceberg when it comes to lakeFS and iceberg. And when it comes to lakeFS and Airflow. lakeFS also has an Airflow operator, allowing you to do these operations as part of your DAG. So you might branch out as part of a DAG, do some things there, commit, and then merge it back also as part of the DAG. We have an excellent webinar explaining how to work with lakeFS and Airflow, which is suggested. And that's about it. So thank you very much. Please come visit us at booth 754. That was great. If there's any questions. Yes, I think I should put this on. I can't hear, so I think he's supposed to come with a microphone to you.
Hey, you can hear me now.
Yeah.
So my question is, whenever you branch off, is this another copy of the data, or how does this work under the hood?
So that's a great question. I can hear myself, so I'll take it off. That's a great question. It's not a copy of the data. We basically manage pointers. So I wish I had that slide, but we basically manage pointers. So once you copy the data, we're just pointing to the same data. And when you add some data, then we're just changing the specific pointers that you add. Or if you override a file, then we'll be changing the pointer. I hope that makes sense.
It does to a certain extent, but when you first import them, do you need to copy in the first import?
Okay, so that's also a good question. So no, we only manage metadata. So when you first import them, it's basically, it points out to the location in S3. So when you'll be using whatever data tool you're using, such as Spark or Airflow, it will just be accessing the data in your It will be reading for the data in your S3 at the time.
Okay, thank you.
Hi, can you hear me?
Yes.
I've got two questions, if I may. So the first question is, does lakeFS only work with file-based formats?
So no, lakeFS is file agnostic. You could choose anything. It doesn't even care what you have in the lake. Any object you put there, lakeFS will manage it.
Okay, thank you. And my second question is, so often when you're dealing with production data and you need to put it into a lower environment, you might need to desensitize some aspects of it, obfuscate. Does lakeFS have hooks to help with that kind of scenario?
So yes, lakeFS has hooks for, like Git actually, pre-commit, post-commit, pre-merge. So it could be used for those cases. It could also be used for like testing your data before merging it into production, because you need to check some stuff.
Thank you.
Hi there, can you hear me?
Yes.
Yeah. The gentleman before stole my question, so I've got another one anyway. So when you talked about sanitizing the data in lakeFS, the hooks in this case, does it take care of as well of, let's say, how does that tie in with the classification of the data, for instance? Like, in order to sanitize it, you need to be able to have it classified. So how do you tie the lakeFS with that kind of capability? Thanks.
So we basically just provide the hooks. The code that runs in the hooks would be something that you run. We could just trigger them. So you could have Python code that you would like to trigger at some time, then you would just add a hook that calls that. lakeFS will be in charge of calling the hook when the operation happens.
Hi, thank you very much for your presentation. Just a quick question with regards to FileFS and object storage. Are there any plans for FileFS to be able to work directly with sort of cloud databases as your source of data rather than object storage?
Currently there aren't any plans. We're just working with object store, but we're working with all of them.
All the
If
cloud
it's,
platforms,
yeah,
Cool. Thank you.
no problem. So thank you very much.